Hola clase, hoy vamos a aprender cómo nombrar los varios químicos. Oh, what? You couldn't understand me? Well, some of you. Why? Oh, you don't speak Spanish, right? So that makes it hard to learn, just like if I was talking about a synthesis reaction to form calcium chlorate, that might be a little confusing, right? Well, chemistry, like any foreign language, has its own rules and systems of naming, and we call that nomenclature. So we're going to learn how to name compounds today. Um, to start off here, you got to understand that we know the valence of some metals, like the alkali metals are +1, alkaline earth metals are +2, group 13 metals are +3, but some metals, like the transition metals, have more than one valence. For example, there's iron 2, which obviously has a +2 charge. Metals always have a positive valence. The Latin name for that is ferrous. And then there's iron 3 that has a +3 charge, loses 3 electrons. That is referred to as ferric. Either one are acceptable, and if you look on your valence sheet, both of these are listed in the second and third column there. Okay, so also on your valence sheet, you'll notice at the bottom some polyatomic ions. Now, these are groups of atoms that have gained extra electrons. They have a negative valence. Oh, there we go, ions with 2 or more elements. So here's one in the bottom middle. It's called sulfate, SO4. It has a -2 valence. But there's also sulfite, SO3. It also has a -2 valence. Since it's in that second column in the bottom there. But notice one letter difference, and it's a completely different substance. Okay, so now that we have that little background, we can move on to looking at your valence sheet and making compounds. All real compounds are a combination of two things. They're either a metal with a nonmetal, so something from the top, something from the bottom, metal with a polyatomic ion, something on the bottom with more than one layer, or more than one letter, I should say. Acids with nonmetals, acids with polyatomic ions, and 2 nonmetals. We'll discuss those later. For today, let's talk about type 1 through 4. Actually, today we'll just talk about the first type, but I do want to tell you that these first 4 types here, all of them except 2 nonmetals, the valence has to add up to 0. We'll talk about what's happening with 2 nonmetals later, but for now, keep that in mind. All right. Naming a metal nonmetal. Rule number 1, write the name of the metal. Pretty easy. With a nonmetal, though, you're going to change the ending to IDE. So, for example, if you have Na and Cl, look on your valence sheet. Na is sodium. See it on the top left. Chlorine on the bottom left. Cl. So to name this compound, we don't call it sodium chlorine. We call it sodium chloride. That's the rule there. Makes sense? All right. And of course, in real life, this is salt. Sodium chloride. So if you want to impress your parents at dinner, say, Mother, would you please pass the sodium chloride? No, maybe don't do that. She might hit you. No, that's my mother. Just kidding, just kidding. Okay, here's another one. Notice this one's different because it has subscripts, but if the valences match up, we don't need to worry about that in the naming. Instead of aluminum sulfur, it's aluminum sulfide. Now the subscripts are there to balance the valence. If you go and you look at your valence sheet, you can test that. But just know that since there's only one way that these 2 elements can add up a total valence of 0, this is the only formula for aluminum sulfide. Let's look at another example. This one's kind of ugly. That was a Spanish joke, yeah. Ferrous oxide is how we would name this. Be careful, because some of these nonmetals, it's hard to tell where to put the "ide." So usually saying them out loud sometimes helps. Instead of sulfuride or side, obviously sulfide sounds most reasonable. Same thing, instead of oxygen or oxygide, oxide is how we name this compound. All right, now there is another acceptable name for this. If you look on your valence sheet, in the top middle, there's iron 3 or ferrous. They mean the same thing. They both are this compound. Now, how did I know it was ferrous and not ferric? Well, look at the bottom middle. Oxygen has a -2 valence. Iron has a +2 valence. So it's really important to make sure that since those two have no subscripts, they're already balanced. It's got to be ferrous. It's got to be iron 2.